Good morning. Welcome to today's webinar on the topic how to assess your infrastructure project's carbon footprint thanks to our EPDs and low carbon emission steels. I'm Jordan from Communication and happy to be your moderator for this webinar where we will know more about how we can pave for a more sustainable infrastructure construction. So our today's speaker will share their knowledge and experience on the dedicated topic. So we will have first Mike Thibault, who is Advanced Bridge Solution and Sustainability Lead from ArcelorMittal Intelligence Engineering. The second speaker we will have today is François Paul. He is Environmental Specialist from ArcelorMittal Sheet Piling. And then finishing with Serge Croet, who is Technical Responsible for CMO Heavy Plates from ArcelorMittal Flat Projects. So we appreciate your involvement and invite you to actively participate in these sessions. Throughout the discussion, don't hesitate to interact with our speaker by submitting a question in the chat. We have allocated a dedicated session at the end of the webinar, lasting approximately 15 minutes, where our speakers will answer your questions. So we would like to thank you again for joining us, and let's make this webinar a valuable experience for everyone. Mike, the floor is yours.
Thank you very much for this nice introduction, Jordan. So I'm happy to welcome you to this webinar, and my presentation will be divided into three parts. In the first step, I will explain the efforts of ArcelorMittal in the decarbonization of its steel production. In the second step, I will show you the low-carbon steel products which are available on the market. Here I will concentrate mainly on hot-rolled sections, and my colleagues will later on talk about sheet piles and flat products. And finally, I will conclude on a life cycle assessment study on the bridge project. So next. So let's first of all start from the big pictures with some numbers. Next. Here we see that the construction industry, also including infrastructure projects in general, are responsible for about 40% of the CO2 emissions globally. So this is, of course, a huge number, and therefore the steel industry has a high responsibility to develop and offer products with a low embodied carbon footprint in order that its customers can decarbonize their projects, especially the infrastructure project, as this is the main topic of today. Next, if we have now a closer look on steel, we see that it is already the most circular material in the world, with recycling rates above 85%. So it has a huge potential to be one of the major backbone of the transition to net carbon, a common aim that humanity would try to achieve. Next. And so if we are talking about decarbonization, so please let me present you the action plan of ArcelorMittal to decarbonize the steel production. Next, please. So here we see that we already launched three climate action reports. In the latest from 2021, we commit to reduce globally the CO2 emission by 25% until 2030, and on the European continent, to reduce it until 2030 by 35%. And if we would like to achieve this, we need, first of all, to look at how steel is produced, and this is on the next slide. So we see here the main production lines of steel that are currently used, especially on the left and on the middle column. On the left column, we have the well-known production line, the blast furnace with BUF. So here we take coal and iron ore. Iron ore is reduced by coal in the blast furnace to produce a pig iron, and then later processed to steel. The main CO2 source is coming from this chemical interaction between carbon and iron ore. And if we also include the emissions from the rolling mill to produce a final product, we see that we have an average between 2.25 and 2.8 ton of CO2 per ton of steel produced. In the middle column, we see the electric arc furnace with a secondary route where we produce steel out from scrap. So the starting point is no more iron ore or coal, but scrap. that we melt in an electric arc furnace using, of course, electricity. That's why the main CO2 source is coming from the purchased electricity. And here the emissions, also including the rolling of the products, lay between 0.62 and 0.85 ton of CO2 per ton of steel produced. So it's already less than from the blast furnace. Still, we have a third route, which is the direct reduced iron route. This one already started in the 70s, but it was only rarely used, and this will play a more important role in future. So what is it? Direct reduced iron means that we use, again, iron ore, but we use this time as a reductant, and not coal, but on short terms now, natural gas. And this reduction process takes place at a lower temperature than in the blast furnace. So we do not produce there liquid pig iron, but we will produce like a solid material, which we call sponge iron, because it has like a spongeous aspect. And this is a solid material that can be pressed into pellets and later on melted in an electric arc furnace. So here the main CO2 sources are, in fact, a mix of the purchased electricity and, of course, of the reductant, which on short term will be natural gas. Later on, in mid and long-term perspectives, we are trying to also replace natural gas by hydrogen as a reductant element. And here we see that the emissions lies between 1.12 and 1.35 tons of CO2 per ton of steel produced, so nearly half of that of a blast furnace. So in the upcoming decades, the steel production will mainly change from blast furnace to this DRI, while the electric arc furnace will still remain, of course, in place because it has already a quite low carbon footprint. So on the next slide, I can show you a little bit how is our roadmap, and we see that it is based on 3 pillars. First of all, we are trying to increase the use of scrap for the steel production. Then we have what we call the smart carbon, which is a carbon neutral steelmaking route that leverages all clean energies like circular carbon, clean electricity, like renewable energy, and also carbon capture and storage technologies. I will show you in the upcoming slides one specific project which is running about circular carbon. And then this is what I already said in my previous slide, there will be a switch from the blast furnace to the DRI route. And of course, on longer terms, we have to replace the natural gas by hydrogen as the key reductant in iron making. So these are the 3 pillars. And on the next slide, a little bit more explanation about the increased use of scrap. Of course, we are continuing to produce steel by the electric arc furnace. But on the other hand, we will also now trying to use scrap also in the production of steel via the blast furnace route, because it allows to further reduce the CO2 footprint of the blast furnace steel making route. So there will be an increased use of scrap in future to reduce the CO2 footprint of our production. On the next slide, we see one specific project about this smart carbon technology or strategy. So it is called Carbolize technology. It is a project which is already in place since last year in December 2022 at our blast furnace in Ghent in Belgium. And what we are doing is we capture the CO2 and all the off-cut gases from the production process. And we put them in a bioreactor to distillate it via microbes to renewable fuels and chemicals that can be then used, for example, to fuel the trucks that transport the steel. And this is one part and one project also of this smart carbon initiative that we have in place to decarbonize the steel production. On the next slide, we have then also next please, yes, the clean electricity. So meaning we will see that if we switch from blast furnace to DRI with electric arc furnace, and if we build out the electric arc furnace route itself, so there will be an increased use of electricity in the future. And of course, the challenge is then to use renewable electricity to decarbonize the steel route. At the same time, we cannot rely on the electricity grid to become more decarbonized as a whole. So currently we are focusing on increasing the amount of clean electricity we consume by purchasing renewable electricity via certificates, and also by direct power purchase agreements with suppliers from renewable projects. On the next slide, we have then the change from the blast furnace to the DRI route. And here we have two steps. In the first step, as I said, on mid and long term, it's to replace the natural gas as a reductant by hydrogen. In the first step, this hydrogen will still be not fully produced by renewable electricity. So it's what we call still blue hydrogen. But in the second step, the idea is also to switch from blue hydrogen to green hydrogen. So this hydrogen will be produced fully from renewable electricity, mainly from solar and wind. And by doing so, we can achieve the target of zero emission steel in 2050. On the next slide, we see just a small summary of the roadmap. So we see to become, at least on the global level, minus 25% to achieve them. This is what I just explained. There are some projects which are already in place. There are some which will still come. And by doing so, we will reduce globally by 25% our emissions until 2030. And between 2030 and 2050, there will be then the big transformation in steelmaking. So the complete change from blast furnace to DRI, and also using hydrogen and using renewable electricity to produce this hydrogen for the DRI. And this will then lead to our aim to be net zero in 2050. So this was a small overview about the decarbonization process, which is currently ongoing and which will still ongo in the upcoming decades. On the next slide, we will then change now to the products, because you see that we are already doing a lot of efforts to decarbonize the steel production. And from these efforts, we have already some products which are on the market and which have a lower embodied carbon footprint than the standard material. And this is covered by our brand, which is called X-Carb. And now I will show you which products are available in X-Carb. But first of all, to explain you what is X-Carb. So we see that there is already a demand from customers for steel with a low embodied carbon. At the other side, all our efforts that we are doing, the customers, by purchasing these products, can take, of course, advantage of our decarbonization investments. And from this, we have two big, let's say, branches of X-Carb. We have on the left X-Carb recycled and renewably produced, which is a steel which is produced in the electric arc furnace. And I will come back to this in a few seconds. And in the middle, we have X-Carb green steel certificates, which are covering steel which are produced in the blast furnace and which represent savings in our CO2 emissions through targeted investments like this smart carbon. And that can be then attached to the steel shipments. But in my presentation, I will focus on X-Carb recycled and renewably produced. On the next slide, we will see what exactly it is. So this is recycled and renewably produced, means that we are using 100% of green electricity, mainly from solar and wind energy, to make work our production lines, so the melting of the scrap, the arc furnace, the alloying phase, and also the rolling mill, and to use up to 100% of recycled scrap. By doing so, we can reduce the CO2 footprint of our product, coming from a global average of the steel production of 2.3 tons of CO2 per ton of steel product, down to nearly between 0.3 and 0.4 tons of CO2 per ton of steel product. Now, how is this exactly working? This is shown on the next slide. So if I say 100% of green electricity, this is purchased via guarantee of origins, according to the European system. This process of buying this guarantee of origin and producing corresponding tonnage of steel, so corresponding to the guarantee of origin, is audited by an independent third party. And when the customer orders this material, we deliver the material documentation, so the standard material and certification, with in addition an X-Carb certificate. And this is then delivered with the final product to the customers. So this is how this process is working. On the next slide, we see some hot rolled sections, so I will base on hot rolled sections which are available under the X-Carb Recycled and Renewably brand. So on the next slide, we see an overview of these sections. So all of our sections which are available in our sales catalog, so from the IPE over the HE, HL to HD, which are the jumbo profiles, ED profiles, with flange thickness up to 140 millimeter, and also our steel grades high star, like the high star 460, where we have a minimum yield strength of still 460 megapascal up to a flange thickness of 100 millimeters. Also steel grade S500M, which is new steel 2090, and also weathering steel, which for hot rolled section is called Arcohox, up to steel grade S460W and a thickness of 63 millimeter according to the corresponding product standard, are all available under the X-Carb Recycled and Renewably produced brand. On the next slide, I will explain you where these products can be used. So hot rolled section in infrastructure projects are extremely economic and ecologic if we use them in span range between 10 and 45 meters. So small span and mid span bridges like filler beam bridges, composite bridges, hanger bridges, where in Poland we have already some projects where we replaced the box section for the hangers by open ice sections, which were cold bent into the form as you can see on the picture, but also preco beams. This is on the left bottom picture, where we cut teeth inside the hot rolled sections to combine or to fix it, to connect it to the concrete slab. And of course, also in standard bridges like trusses, true bridges, or temporary bridges, these sections can be used. On the next slide, I will then deal with the question how you can calculate the carbon footprint of your project. How can you have a feeling of how big is the CO2 footprint of your infrastructure project? And to do so, this is on the next slide. You can carry out a life cycle assessment, but first of all, you have to know what are the different life cycle stages of your project. And here we can see that we start on the bottom right section with A1 and A3, which covers the production stage of the product, for example, of the steel beam. So A1 is the supply of the raw material, scrap, iron ore, coke, for example. Then A2 and A3 deals with transportation to the fabrication mill and also manufacturing inside the mill. And then came A4 and A5, which is the transport to the construction site, as well as the installation and construction on construction site. Then we have also B stages, B1 to B7 covers the use stage of your project. For a bridge, it would be, for example, the refurbishment of the deck, like replacement of the supports and also of the corrosion painting if you do not use weathering steel, where this is not necessary. Then you also have module C, which is the end of life stage, so the deconstruction, demolition, transport to waste processing or disposal. And finally, we have module D, which deals with the recycling of the materials. So these are the different life cycle stages of your project. In the next slide, I will show you how you can assess the CO2 footprint of these life cycles or life stages. This is done by life cycle analysis. The goal of a life cycle analysis is to know and to compare the environmental impact of systems throughout its life cycle stages. So the life cycle stages I showed in the previous slide. Next slide is what is an LCA? It is a mathematical model of transformation used to match the flows with the environmental impacts. So you can, for each stage, quantify the CO2 footprint of your product or of your project. In the next slide, what it is used, so it allows to quantify the contribution to a system's environmental impact, for example, of your infrastructure project, of a bridge, for example, in order to identify the eco-design option or ways to improve the system's environmental balance, and also to compare from an environmental point of view to a system with the same function and for the same quantity of service rendered. And this is a life cycle analysis. In the next step, I will show you how you can use this life cycle assessment. It can be used on the product level, for example, on the hot rolled section, to generate a corresponding EPD, an environmental product declaration. So for the different life stages of this product, of the hot rolled sections, for instance, we calculate for each of the stages the CO2 footprint, and then we get what we call an EPD. And this is an instrument to communicate in public about the key environmental impact of a specific product. And these EPDs, these are scientifically based, also on dedicated standards, and they are independently verified. So if I say the key environmental impact, it is mainly the global warming potential. So the global warming potential, it's a contribution to the greenhouse effect from a suite of greenhouse gases. And that's why we are talking about CO2 with a small e, as you could see, because it's an equivalent CO2 because it covers a different suite of greenhouses, the contribution to the global warming potential, and it is not only the CO2 itself. On the next slide, you can see then an EPD which is already available for our hot roll sections under the X-Carb recycled and renewably produced brand. So we see here that for the sections, for the stages A1 and A3, so from the supply of the raw material to the gate of the mill, so when the product leaves the mill, we have a carbon footprint of 333 kilograms of CO2 equivalent per ton of steel produced. And this EPD can, of course, then be used in your life cycle assessment of your project, infrastructure project, to quantify the CO2 footprint of it. On the next slide, and an important information is also that this EPDs covers also our high star grades and also our weathering steel for hot rolled sections, which we called Arcorox. On the next slide, you can see that we also have national EPDs, let's say, which are more dedicated to the national requirements of the specific European countries. Here you see, for example, the FDS for France and also an EPD for the Netherlands. You see they are all about the same value. Here we have 388 and 386 kilograms of CO2 equivalent per ton of steel produced. So on the next slide, I will show you then an LCA study on a bridge which has been constructed in France. It's a bridge in Rosières-aux-Salines in France, close to the Luxembourgish border. And here we applied the LCA not on the product level, but we are using it on the product itself, on the project itself. So the initial variant, and we can just go to the next to show the bridges. So we see the bridge has a total length of 108 meters, and it was initially foreseen in pre-tension prefabricated girders made from concrete, of course. And we have a 4-span bridges and a bridge, and it was done in situ concrete in C3545 with a concrete slab thickness of 21 millimeters, and the total tonnage of the whole bearing structure was 1,050 tons. If you click next, we can also see then the section. So this was the initial proposal, and we worked out an alternative in composite structure. This you can see on the next slide. So for the variant, of course, the total length remained the same. However, by switching from pre-stressed concrete to hot rolled sections in composite, we could gain 1 span. So we came down from 4 to 3 span, as you could see. The width of the section remained, of course, the same. And what did we use for sections? We used hot rolled sections HE that we weld to a box. So we had 4 box sections in S460M. That is high-strength steel for hot rolled sections, because by switching to high-strength steel, you can reduce the section size and gain additional, save additional material and also the weight of your project, of your bridge. It was done as a combination with in situ concrete slab, which was cast on filigree pre-stressed concrete in C3545, and the tonnage of the steel structures was only 260 tons. So by using this high-strength steel, and here you could see how we welded the hot rolled sections at the level of the flanges together to form this box section. Now, on the next slide, we can see some pictures of the bridge as it has been finally realized with these box sections in France. And on this, we applied an LCA study. This is on the next slide. So here we have an LCA study for the different variants that we analyzed. On the left, we see the LCA, so the global warming potential A to C, so from cradle to grave for the pre-stressed prefabricated concrete girders. In the middle, we see the same for the steel variant, so the steel composite variant, as it has been finally realized. And on the right, you see the same with our X-Cup recycled and renewably produced steel. At that time, the product was not available under X-Cup. That's why we realized it as shown here in the middle diagram. But you can see, first you could see that the salmon color is dominant, and this is the global warming potential coming from the construction materials and the stages A1 and A3, which is dominant here for this bridge. And you could see that by switching from concrete to the steel concrete composite deck, we could already save 12.5% of CO2 equivalent. And if it would have been possible to use then X-Cup, we can see that we compared to the concrete solution, we can save additional 22.8% of CO2 equivalent. To show you a little bit that it makes sense to combine so low emission steel products under X-Cup recycled and renewably produced in combination with a clever design, so using high-strength steel in combination, for example, with hot-rolled sections to further reduce the material input of your project and to reduce the CO2 footprint of your infrastructure project. So I think that was my last slide from this, and now I will show you two more pictures of recent realized projects in X-Cup recycled and renewably produced. Here we see one bridge which has been realized in Luxembourg. It's one of the longest pedestrian bridge. It's made in X-Cup recycled and renewably produced, and it was inaugurated last year. And on the next slide, we can see a bridge that we realized in Osmolice in Poland. This was a combination of weathering steel in combination with X-Cup recycled and renewably produced. By using weathering steel, we save the anti-corrosion protection, so we do not need to replace them. So the maintenance activities are dramatically reduced, and also the environmental impact is reduced because we do not need to replace the painting or to put it first during the construction. And this was a single span bridge, which hot rolled sections HE 900B, which was realized last year in December 2022. So, and this was from my part. Now I would be happy to give the floor to my colleague François Foul.
Thank you, Mike, for this, very interesting first part. Well, I will go on with sheet piling solutions. And for those not familiar with the product, or just to, let's say, start the presentation, I would like to focus in the next slides on the main application domains of sheet piles. Well, if we skip 2 slides, in fact, you see that, next slide, please. Yes, exactly. So here you see the main applications for sheet piles. On the left, you see we have solutions for mobility infrastructure. Here you see, for example, a retaining wall, an underpass in the Netherlands. And to this, you can also count, for example, bridge abutments, and there I will focus a bit more on the next slide. Then we have water transport solutions. There we are mainly talking about ports, but also, river embankments and similar stuff. Then we have hazard protection, which is, quite related to the water solutions. This is mainly about flood protection, but also, reinforcements of dikes. Then on the right-hand side, you see a picture that I like to explain a bit more. Those are solutions for the environmental protection. So here you see a temporary cofferdam made with sheet piles that was installed to, let's say, to avoid further pollution of this river in Spain. To do a bit the link to the presentation of Mike, we can see on the next slide some projects that are linked to mobility infrastructure. So you see, you can use sheet piles near to railways. You can also use it, this is very interesting, as a permanent retaining wall in an underground car park. There I will show afterwards life cycle assessment on a specific project. And then the two pictures on the right show also the permanent use of sheet piles as bridge abutments. Then on the next slide, we see indeed our product range. I won't go into detail, but this is also important afterwards to explain our X-Carb brand and EcoSheetPile Plus. So you see that ArcelorMittal has in fact 3 mills to produce sheet piles, and actually all the AZ profiles, all the PU, AU and AS500 sections are produced in Luxembourg. The same is the case for our HZM section that can be used for combi walls. This is mainly the case for port structures where we need high inertia and high stiffness for sheet piling solutions. And then in Dąbrowa, in Poland, we still produce the GU sections in 400 and 600 width. And so why do I show this? Well, all the sections that are produced in Luxembourg are available in EcoSheetPile Plus, and EcoSheetPile Plus is in fact our X-Carb brand. It's part of ArcelorMittal's X-Carb initiative. And so all these sections are available right now in 100% recycled steel and produced with renewable electricity. And if we compare the emissions of the production of EcoSheetPile Plus to conventionally produced sheet piles, we can say that they emit 83% less CO2 equivalents in the production stage, which is of course enormous. On the bottom you see the graph that was also shown by Mike. So you see that the main part of the electricity is really used for the electric arc furnace, but also the rolling and the ladle furnace, of course, they need some electricity. On the right, you see our EPD that is published at EPD International. And there you can see that for EcoSheetPile Plus, there is a stated global warming potential of 409 kilograms of CO2 equivalents per ton of finished product. If we go to the next slide, we can indeed also see that equivalent to sections, we have country-specific EPDs. This is the case for France, where we have published an FDES. We have also a national EPD for the Netherlands and one for Belgium. All these EPDs you can find at the respective websites of the program operators, but also on our ArcelorMittal sheet piling website, where you can download it and have a closer look at them. So if we now go to the next slide, I want to explain, in fact, some basic principles of the circular economy and also focus a bit on weight reduction in sheet piling solutions. All this is related, of course, then to reductions in CO2 emissions. So after we've done this, we'll show also 2 LCAs on a project basis. The first one will be an analysis of an underground car park where different technical solutions are compared on the basis of a life cycle analysis. And the second one will be a study that also shows the optimization potential that is really there when using X-Carb steel. So let me focus on circular economy first. Circular economy is generally defined by the reduction of energy flows, the reduction of waste, and normally there are always the same keywords that play a role there. The three most important are reduce, reuse, and recycle. And if we now have a look at reduce, we can really say that sheet piling solutions have become more and more efficient over the last decades. This is mainly due to efficient profiles, but also to high strength steel grades. But we can go back one slide first, and then we'll continue. Thank you. The second one is reuse. So sheet piles can be used in temporary and permanent applications. And in temporary applications, we can say that a sheet pile is normally used 5 times before it is scrapped. So we leave it really at a high circularity before it is recycled. And depending on the soil and the section, we can also say that it goes up to 10 times really. Recycling, I won't focus on this, but it is an easy one for steel. Steel is recyclable to 100%, and it can be recycled without any loss of quality. And so all our sections that are produced in Luxembourg are based on recycled steel. Now we can go to the next slide. So here you see, in fact, 2 quite recent profiles. And there are some differences that are obvious. The AZ800 on the right-hand side is larger, it is deeper, but it is also optimized in that sense that we have less steel in the steel web, but more on the steel flange. And if we now go on to the next slide, to the next step, we see that for a similar elastic section modulus, we can really save 10% of mass, and this means we can save 10% of CO2 emissions in the production. There you see another comparison to a section from the 50s. The difference is even higher. On the next slide, we can have a look at the other parameter. So in fact, high strength steel grades, just as Mike Thibault has explained it, also allows us to save steel mass and reduce CO2 emissions. If we now go on to the next slides, yes, we see that there are few efficiency gains that are possible. So an S355 is the absolute standard in sheet piling, and if we go on to a higher steel grade, there are huge savings in CO2 emissions possible. And those two parameters we can put together, and that we see on the next slide, where you see on the x-axis the yield strength of the steel, and on the y-axis the elastic section modulus, which means more or less the weight of the section on the y-axis. So you see that in fact this blue line represents technical equivalent solutions. And if you go on with the steel grades, if you go down the road here, you can choose a lighter section. So we're going here from AZ44 to an AZ36. And again, for this very simple example, really, we can say that we can save 26% of mass, and related to this 26% of savings in CO2 equivalent emissions in the production stage. So the next slide, please. We see here, that's what I promised, a life cycle assessment on the project level. This was done in 2020 by this study on the basis was done by an independent design office in the Netherlands. And then based on this, we have an LCA report from our ArcelorMittal R&D, which is of course also peer-reviewed. I can only show the summary of the study and the synthesis, but if you want to have a closer look, we have really detailed documentation about this on our website, where you can download this, of course. So we see on the left table that for this study, 4 technically equivalent solutions were examined. Of course, the sheet pile wall is part of this, and then we compare it to a cutter soil mix, a secant pile wall, and the diaphragm wall in concrete. And just to explain again a little bit what it is about, we're talking about a permanent sheet pile wall as part of the building envelope that is used in an underground car park. This is a very efficient method that also generates space inside the parking and has a big influence also on CO2 equivalent emissions. You see that the sheet piling solutions is the best in terms of global warming potential, and compared to the next best solution, there is a difference of 88% of CO2 equivalents for the entire project. Of course, there was also a sensitivity analysis that was done, and even with a quite high corrosion rate that was considered in this case for the sheet piles, we are the lowest in global warming potential. Then we can go to the next slide, where I want to show another case study. Here we talk about a new K-wall for a port in Germany. This project is realized right now. Key characteristics of this project are a quay wall, of course, that is 650 meters long. This quay wall generates a need for sheet piles of nearly 1,280 tons. And indeed, for this project, we delivered sheet piles in Eco Sheet Pile Plus quality. Just to remember, those are our sheet piles from the X-Carb brand, which are produced on 100% steel scrap, and 100% renewable electricity. All this was delivered in an S355 GP. You see here on the right the cross-section of the project, and you can see that the new K-wall is in fact installed in front of the old one. If we now go to the next slide, we can see the life cycle assessment that was done for this specific sheet piling tonnage. Also important to mention is that for an infrastructure for a K-wall with sheet piles, if you consider the sheet piling tonnage and maybe a capping beam with concrete, you have considered more than 90% of the environmental footprint of this project, because the use phase for infrastructure project is normally generally neglectable, because you don't have a heating, you don't have a cooling over 50 years. On the left, you see, in fact, the whole life cycle for this sheet piling tonnage. Let me focus on the production stage, where we have a global warming potential of over 520 tons of CO2 equivalents for this tonnage. And also interesting, I think, is the transport. The transport was done, or is done right now, with by truck from Eschbergwald in Luxembourg to Germany. And you see that related to the emissions in the production stage, it is quite low indeed. Then on the right-hand side, you see the as-built situation with a focus on modules A1 to A3, so the production stage of the steel. And here you see the 520 tons. It's the as-built with Eco Sheet Pile Plus. And if we compare this to conventionally produced sheet piles, let's say over the blast furnace route, we can see that there is a huge efficiency gain in terms of CO2 emissions for this specific project. Around 2,600 tons of CO2 equivalents were saved in the production stage. Then we can go to the next slide. This is just to show that it is not just gray theory, but this is the actual K-wall in Kiel, Germany, which is built right now. And we can go to the next slide, please. This is just to mention that also we deliver life cycle assessments that are tailor-made and project-specific. So for a specific tonnage, for a specific transport mode, and so on and so on. Then the next slide, please. This is now a small summary. Just to recap, what is the optimization potential regarding CO2 emissions in sheet piling solutions? So we can start off with the 3 first rows that are all reduce strategies. So first of all, it is of course an option to choose the right construction method. That is what we've seen in this LCA study from the underground car park. Then there is a choice of the steel production route where we offer our X-carb range that is produced on scrap basis and with renewable electricity. Again, there is a potential in using optimized profiles and high-strength steel grades also. And then we go to the other strategies that are reuse and recycling. So also reuse is something that is really important and done on a daily basis for sheet piling. And recycling that I explained in the beginning is also an easy one for steel. On the right-hand side, you see again some bullet points. What are we talking about when we say optimized sheet piling profiles? Well, mainly they are CO2 efficient. On the one hand, in the production, but also in the transport, less mass. They are cost efficient. They are generally faster in installation. And depending on the projects, we are quite happy when there are less interlocks, because then there is also less possibility for seepage. That's it for that slide. And then there is another nice picture from a project in France, where we delivered also nearly 1,000 tons of HZM solutions. Here you see the kin piles that are installed to have a high inertia and high modulus retaining wall. Then we go to the next slide, and that's it from my part. And I would give over to Serge Croet, who is responsible for the part about heavy plates. There you go.
Yes, thank you very much, François. So I'm very happy to participate to this webinar because there are a lot of, so there are different branches in ArcelorMittal. So you could see a long sheet piling, and now you will see the other side with flat product. And also what is very important is that the way to produce is different, because the long they are mainly electrical arc furnace, and in flat we are mainly blast furnace. So you will see that our figures in the EPD and the products, we are starting from higher values, but our effort is also there. So please, next slide. So you will discover all the applications for heavy plate, but not only, there is also a small one slide to show you also what is available in coils. Next, please. So key facts. It's very important that building infrastructure, so it's a very big part of the consumption of steel worldwide. So it's very important. On top of that, also, we don't deny that iron and steel production is responsible for around 7% of the global CO2 emissions. So we have a part in that. And after speaking about the flat products, you have to keep in mind, so we will see later all the details, but just keep in mind that we produce around 2 tons of CO2 for 1 ton of steel produced. And we will see that for heavy plates, it's a little higher because we have a normalization furnace, so consuming more energy and CO2 and emitting CO2. So next, please. So some facts. And now, but of course, the commitment, and it was already presented by Mike, so I will not give more details on that. So what is very important is the reference. So when we give a percentage, so it's important to understand the perimeter if you are in Europe or if you are global. Also, the scope is very important, 1 and 2. So 1 is what is going out from the chimneys, 2 is electricity to simplify, and 3 is the rest. So for example, ferroalloys are in the 3. So the reference is 2018, and we compute everything according to this baseline. So committed for net zero in 2050, and also science-based target initiatives. We are also committed. So next, please. So we are committed. So now giving little information about heavy plates. So what are we talking about? So we had in the past other mills in USA that we sold. We had also the experience in Italy with Taranto. So now we have only 1 heavy plate mill in Gijón, in Asturias, in Spain. So the products are between 6 and 150 millimeters according to the steel grades. The width, it's from 1.5 to 3.3, and the length starting from 4 meters and now 25. So it's a very recent extension that we made mainly for the wind market. We're going for always bigger wind towers. And the weight, it's a quite good asset on the market. So we can go up to 18 tons. For that, and to reach this weight, in fact, we had a revamping of the continuous casting in Avilés, because you need to go for higher thickness slabs, and we can go until 365 millimeter. So next, please. So what are the markets? So of course, construction infrastructures, but not only. So I talked before about the wind segment. Bridges also, it's a part. So offshore platforms linked to wind market. Shipbuilding is very important. We are the unique supplier of Chantiers Atlantique in France, for example, but not only. So Spanish shipbuildings are also very active, and we are present. Pressure vessels is also some assets from our Riron plant. Line pipe, yellow and green goods, so something very classical on applications. So next, please. So here it's also it's a more a vision from flat. So we are always concentrated on our branch. So very important. It was mentioned that there is a green seal certificate. So it's not about a product. It's just to transfer our CO2 savings to customer, and you can put it out of your accounting in CO2. So we will not detail that. So we will concentrate on the physical products, the recycled and renewably produced. So what is available. So it started later from 2022. So from coils, we have only 1 plant in Sestao close to Bilbao, and for heavy plates, I will detail you what is our solution. So we'll concentrate on that. Coming next, so from 2026, so there will be some new products, but it's too soon to disclose that. So it will be linked. So some announcements on the markets already, that the Dunkirk plant and the Ghent plant will get this DRI and electrical arc furnace technology, and so it will start soon. Next, please. Yes, so about the offer of recycled and renewably produced, so for heavy plates. So in fact, it is something which is, the slabs are produced via an electrical arc furnace plant. with almost 100% scrap. So we say almost because you can have some cases you have to use something else, but very close to 100%. And why? Because you have a better performance in the A1, A3 section, so a lower value for CO2. So that's why we decided. And using, of course, that's the definition of the RRP, 100% renewable electricity. So with all that, we can reach a value of 914 tons of CO2. It has to be compared with the standard value that we have on the rerun plant, which is at 2.6. So making 65% of reduction. So of course, the electricity is controlled and verified with a guarantee of origin. And we have EPD. It's something very recent from October. So we will see that later. You have the photos on the right side of this EPD. So the production it is EAF. We will detail that. We will benefit from the slabs of industrial sister company making slabs, and so that we are physical steel plates with a reduction of CO2 of around 65%. I told you 2.6 going down to 0.914. So what is the route? We start the production at Charleroi, Belgium, with nearly 100% scrap and 100% renewable electricity. That's the definition. Then there is a transport from the Charleroi plant to the rerun plant, and we decided to do that mainly by ship. And you have a small portion with trucks, and you will get 50 kilos of CO2 counted in the EPD. So that's small. And then you have the rolling, standard rolling at the rerun plant. And this will lead to 914 tons of CO2. So please next. So how it is documented? So the EPD document, all are the EPD of ArcelorMittal. I mean, from all the product. It is long sheet pile, tubular products. They are all on the same site. Yes, they are accessible, and it's a public document. After, of course, to claim for it is you have to enter an order which is flagged RRP. And so there is a special agreement with your account manager representing ArcelorMittal at your company. And so you will get the very standard mill test certificate. That's will no change on that. But additionally, you will get an X-Carb RRP certificate with 2 pages. So on the first page, you will get all the standard information about the order, the name of the company, the information about the norms that were used to create the LCA verification, the link either to the site, and you will get also a QR code doing the same. So it is signed by the top managers. And on the second page, as it is physical product, so you will get the list of all the products that you can claim for your reduction or accountability of CO2 in your books. Next, please. So here, I told you that I will present you all the flat products about the EPDs. That's a very nice synthesis. You could see with only 1 page where we are. So I told you already about heavy plates, and from 2.6, we will go down to 0.914. You have also, and it's based on the industrial Charleroi slabs. You have the same for hot roll coil, and we start by that because the manganese and the organic coating, they are made with this substrate. So Sestao can reach a value of 532 kilos. And the 2.23, it's an average of all the plants producing hot rolled coils in flat Europe. And so it's an average value from all the plants. Then after using this substrate and with some constraints on the transport, because it must, truck is absolutely forbidden. There is the very well-known magnelis, the hot dip galvanized product with magnesium. You start with a standard value of 2.57, and if you use coils from Sestao, you can reduce with 70% about CO2, so reaching 0.797 tons. Then about the organic coating, higher, because you know organic coating is based on hot dip galvanized plus painting, so that's why the value is a little higher, so 2.72, and with the substrate of Sestao, it's about let's say one ton of CO2 generated for this product, which are used a lot in for panels on buildings. So that's a very good synthesis, and you have to keep that in mind with all the figures of what you can do on flat products. Next, please. I will end the presentation by an example, an application of X-Carb RRP. So, of course, we must apply that to ourselves. So, in Luxembourg, there will be the new ArcelorMittal headquarters in Kirchberg, exactly, and they will use X-Carb RRP products. Here, I will speak only of heavy plates, but it's not only heavy plates in this building. There are also sections. So the foundation just started, so this year, and we will deliver the RRP heavy plates beginning of 2024, and the building is due for completion at the end of 2025. So a very nice architecture for the pride of our group, illustrating RRP. So yes, thank you very much for your attention. And I think that we are at the end of the webinar, and that we will go, Jordan, for the question and answers with all what has been posted on the panel.
Yes, thank you to the speakers for the clear presentation. So as Serge mentioned, now it's time for the Q&A sessions. So the first question we have in the chat is, for the bridge in Rosières-Rossaline, was an alternative with welded plate girders considered with hybrid sections? S460 for flanges and S355 for webs considered? If so, would it be better or worse in terms of CO2 emission?
Yes, I can reply. So in this study, a hybrid section, S355, S460, has not been considered. So here, unfortunately, I cannot give any statement if it would be more or less CO2. On the other hand, of course, we should also think about the budget for such a project. So hybrid beams will also have an impact on the budget, of course.
Okay. As another question we have is for the same bridge. I noticed that the concrete deck slab thickness varies significantly on the cross section, from 225 millimeters and then to 400 millimeters. What was the main reason for this solution, please? And could the thickness be optimized to a constant thickness and cast following the cross wall? For example, with steel girders set at different levels.
Yes, exactly. So the main reason for this was the drainage slope of the bridge of 2.5%. That's why the thickness of the slab was varying. Of course, an alternative could be to put the girders at different levels. This also depends on the specific project, because you need, of course, the space to put them, and it's also an architectural point of view if the girders are not at the same level, if this is accepted or not. But this is an alternative, yes.
Okay, thank you, Mike. We have another question for the EPDs, rolled section and sheet piles. Do you have the values for the UK?
I can take over for this one.
Yes.
Well, behind curtains, I discussed with Mike, and we definitely agree that there are no specificities on the UK market for EPDs. So just to explain why we have country-specific EPDs sometimes, well, for France, there are specific requirements, as well for the Netherlands. There they require 4 or 6 more indicators that are about toxicity, and they are normally not published in other EPDs. But for the UK, feel free to use our EPD that is published at EPD International, and for Mike, it would be the EPD at EBU. They are definitely good to go and valid for the UK market.
Thank you. I think that was the last question we had. So if you have other questions, feel free to do it now. If not, then we have reached the conclusion.
Sorry, Jordan, there is another question. There was another question for me about the development of wearing steel for heavy plates in X-Carb P. So
ArcelorMittal produce weathering steel in
yes,
X-Carb and in S460 grade, or are some
exactly, yes.
So
very good question. So the person is reading our mind and maybe has access to our development plan. So yes, it is in the plan. So as I mentioned, the first market of interest and the one that we will get some success will be the wind, the wind segment. Second is we are working on the naval, also the naval segment, with some projects in longer term, but you can see that in the EPD, some grades, naval grades are already present. So that's a second market emerging. And the third market is weathering steel. So we are developing that, and it will start beginning of next year. We will go for the first trial on that to complement the EPD document on this special grade. Now, the other question about S460N, I mean, this is later on. It's not the first priority, so we'll come after, because I would say that for the moment, less demand on this special grade, so we put it later in the list of priority.
Thank you, Serge. I think as we finish the question, so we can conclude on today's webinar. So we hope the information presented today has provided you a deeper understanding of sustainable construction practice. Before we conclude, I encourage you to explore further by visiting our website for additional resource, case study, or if you have any remaining questions, please don't hesitate to reach out to our team via the email we will send you afterwards. So thank you and have a very nice day.